In this video, we're going to take a look at question number 6 from the 2011 AP Chemistry free response questions. And how question 6 goes is they say, in an experiment, all the air in a rigid 2-liter flask is pumped out, then some liquid ethanol is injected into the flask, which they hold at a temperature of 35 degrees Celsius. The amount of liquid ethanol initially decreases, but after 5 minutes, the amount of liquid ethanol in the flask remains constant. Ethanol has a boiling point of 78.5 degrees Celsius and an equilibrium vapor pressure of 100 torr at 35 degrees Celsius. When the amount of liquid ethanol in the flask is constant, is the pressure in the flask greater than, less than, or equal to 100 torr? The key thing here to answer in question A is they are going to hold the temperature at 35 degrees Celsius. So what I would say in A is if the temperature is held constant at 35 degrees Celsius and there is only ethanol in the flask, then the pressure will be equal to 100 torr because the liquid and gaseous ethanol will reach equilibrium. And then I would just say what they said to in part, or at the very end of it, the equilibrium vapor pressure at 35 degrees Celsius will be 100 torr. Okay, kind of a random question, but maybe it'll be important for other parts of this. The flask, so I'm looking at part B, they say the flask is then heated to 45 degrees Celsius and the pressure in the flask increases. Okay, that makes sense. In terms of kinetic molecular theory, provide 2 reasons. This is a very common question they ask on the AP test, why the pressure is going to be greater. Okay, so when you take the AP test, you should be prepared to answer this exact question because I can almost get up to 5 times where they've asked that exact question to give 2 reasons why the pressure increased at a higher temperature. So the pressure in the flask increases. There's actually more than 2 reasons, but we just need to provide 2 because the vapor pressure of ethanol increases as the temperature increases. This is because the ethanol particles have a greater kinetic energy and can escape the liquid phase and enter the gas phase with greater ease. Let me make sure. And then I would say with more with more gas particles present, the pressure will increase. And then I'm thinking back to my answer, and I just want to make sure that I get my points. So I think I have enough to get my points, but I'm going to add another reason just to be certain. Additionally, with the higher temperature, the gas particles, I should say, the gas particles hit the walls of the container with more frequency and force. And now I feel like no matter what, I'll get my points on part B. Okay, now it says, in a second experiment, which is performed at a much higher temperature, a sample of ethanol gas and a copper catalyst are placed in a rigid, empty 1-liter flask. The temperature of the flask is held constant, and the initial concentration of the ethanol gas is 0.01 molar. The ethanol begins to decompose according to the chemical reaction represented below. The concentration of ethanol gas over time is used to create the 3 graphs below. Given that the reaction order is 0, 1, or 2, use the information in the graphs to respond to the following. So before I even read parts 1, 2, or 3, this graph has caught my eye because it's a straight line. And we know that we are typically looking for the kinetics graph for the integrated rate law that gives us a linear relationship. Okay, so in part 1, it says determine the order of the reaction with respect to ethanol. Justify your answer. So that should be a relatively straightforward question. I would just say the reaction order with respect to ethanol is 0 order, and the reason why is that this is because the graph of ethanol versus time produced a straight line. Okay, that's good enough for us here. Okay, part 2 says write the rate law for the reaction. Okay, this is kind of weird, and I can see how back in, what was this, 2011, kids might have gotten stumped on this, but we can say rate equals K and then C2H5OH to the 0 power, or you could say rate equals K, which is kind of weird. And then in part 3, let's see what they say. They say determine the rate constant for the reaction, including units. So let's see if there's a couple ways that we could do this. And they're actually the same way. So one way is you could use the slope, which is equal to rise over run, which is equal to y2 minus y1 over x2 minus x1. Or we could use the integrated rate law, according to our formula sheet for 0 order, which is a sub t minus a sub 0 equals minus kt. And we know that the absolute value of the slope is going to be what our k is. So I'm going to use just the slope. And if you think about it, this equation that I've just circled is actually just a slope equation. It's just rearranged. So the points I'm going to use are 0 comma 0,01, and then I'm going to use 2000 comma 0.002. Okay, and I'm just going to find the slope here. So I'm going to do that down here. So 0.02002 minus 0.1 or 0.01. I can't talk today apparently. 2000 minus 0 absolute value, and we get 4 times 10 to the minus 10, and the units of that will be molarity seconds minus 1 or molarity per second. Because we don't have any concentration here, the units of K have to be the correct units for rate. Okay, last part here. D, it says the pressure in the flask at the beginning of the experiment is 0.4 atmospheres. If the ethanol completely decomposes, what will the final pressure be in the flask? So I look at this as almost like a stoichiometry problem. 0.4 ATMs, we have 1 gas mole, and we are going to produce 2 gas moles, so the pressure should be double. So in D, I would say, since 1 ethanol gas molecule reacts to produce 2 gas molecule products, there will be twice as many gas particles if the reaction goes to completion. Thus, 0.4 ATM of ethanol would result in 0.8 ATM of product.